Yeah, hello, wonderful people. Good evening. Let's meet again. We are meeting again here for Cat Ninjas session on time, speed, distance, the boats and streams. We will learn some of the approaches for boats and streams. The concepts are pretty simple, but approaches and the types is all just we have to know. So once we know them, so we are good to do some of the Cat questions. As usual, we start with some basics and quickly understand the basics, and from there we go to the Cat question and try and do couple of cat questions before we close the lecture. We'll stick to the same format that we are doing out there earlier as well. Let me quickly check. So is everything fine out here before I commence the rest of the journey? Okay. All right. Is the audio clear? Someone quickly confirm. Is the audio clear on this? Is my audio clear? Are you able to hear me out clearly? Good evening, Prashant. Good evening. Good evening. All right. All right. Good evening, Mohit. Nice. All right. Fair enough. All right. So let's get started on this note. So quick background about me. So I'm Belvi Srinivas. I worked with various test prep industries in the past, 14 years, and since 2007, that's about 14 years now. In various capacities, of course, both in terms of training as well as in terms of management. And I have developed expertise in training students as well as trainers in the area of quantitative aptitude, DI, and DLR. Fairly okay with verbal as well. That's a little bit of background about me. And if you have to reach me for any suggestions or counseling, you can note down this chat ID of Telegram and then you can ping me out there. So I will be able to reach out to you with a response for your concern. All right. So on this note, let's kind of get started. So what we do, as I said earlier, so we'll kind of first learn a bit of basics, refresh the basics, what we learned from high school. Once we refresh the basics, then we will look at some of the CAT questions. Of course, we do the drills, and then we'll come to the CAT questions. All right. Okay. So who all have joined? Prab has joined. I don't know. The name should be Prab, or it should be little more than that. Kushagra is here. Good evening. Stuti is here. Good evening. Right. Okay, great. All right. Now let's get started on this. So let's get started on this. So before we get started, let me quickly allow me to do quick announcements out here. Then we will get started there. So Unacademy offers two kinds of subscription. One of them is a plus. The other one is an iconic. Iconic is more about more from the perspective of iconic allows us to do. Okay, guys, just a second. Mhm. Right. Okay, iconic is technically iconic will allow us to iconic will give a kind of one-to-one interaction, the various of the study materials and the test and one-to-one interaction, whereas plus is the very structured course with respect to the batches, and these are the subscription fees for the plus as well as for the iconic plus on the iconic. And then if you use the code belvi 100, you will not get 100% discount, so you will get 10% discount so on whatever that you are looking at. So if you're looking at even downloading the app or whatsoever it is, use this particular code and that would be encouraging to both of us. So here is the iconic subscription fee. So there we go with the lecture. Fair enough. So let's come to this. So what is this boats that we are kind of looking at? One, so basically here there is a boat in still water, would have some speed, right? So you have to allow me a little bit of time here, guys. I may have to delete a particular a kind of a bit of apps here. So I'll be back in a moment. So let me delete some apps here. Then we'll be back. Otherwise, the storage space keeps killing us through the lecture. Right? Give me a minute. Let me delete and create some storage space. Yeah, I guess it looks good now. So let's get started. Okay, so the basically the boat speed in still water, I will take B as the boat speed in still water. So assume the constant speed of the boat. So technically what we have is we have a boat which can move in still water with certain constant speed, right? That's automated boat. You just have the boat, you put that boat in the still water, it moves with certain amount of speed. That's what it means to us. Okay, then I will take W. I will take W as the speed of the water current. That's a river or whatever it is, water current in one particular direction. So these are the only two variables I kind of use through this particular lecture. So W stands for the water current and the water current speed, and WB stands for the still water speed, right? These are the two things. And let's say that, okay, if there is the water moving in this direction, effective speed is the word that we use. If there is a boat kept on this and the boat is moving in this direction, naturally water is also moving in this direction. So boat speed is B and the water current speed is W. Therefore, the effective speed, we also call it as the downstream speed. That's another word that you find here, downstream. Very easy, moving down the stream. Downstream speed, the effective speed will also be B plus W. Right. On the other hand, if I keep this particular boat out here, so if I keep this particular boat out here and make it come in the opposite direction, the water is moving in this direction, of course, and the boat is moving in the opposite direction, B here and W here, then we call something as upstream speed here. We call this as upstream speed. Upstream speed is nothing but B minus W. That is when the boat can come up. That becomes the upstream speed. Right. So these are the two jargons. Jargon wise, effective speed. There is something called as the downstream speed. There is something called as the upstream speed, and B I am taking it as the still water under the water speed of the speed of the boat in still water. W we are considering it as the speed of water current itself. Now this is all the four parameters here. Now this is what we used to call it as relative speed earlier or effective speed, whichever way that you kind of think about here. But there is a downstream speed and there is an upstream speed. Fair enough. This is all the fundamentals out here. Rest everything comes from whatever we did in the past. So three things: relative speed, your understanding of relative speed should be clear. Your understanding of average speed should be clear. Your understanding of relationship between time, speed, and distance should be clear. All are built on these three concepts, and that's what we'll see here. But with respect to the boats and streams, we will examine the same concepts out here there as well. Okay, all right. So let's get started with the lecture now. On this note, let's get started with the solved examples. Let's take some of the solved examples. So there are two models, two primary models here. Let us try and understand how do we technically solve in more often than not. Remember, most often structure used is the time taken for upstream journey plus time taken for downstream journey is equal to total time taken. I don't know. For most of the reasons, you find this as one of the patterns. One of the patterns you find is time taken for the upstream journey plus time taken for the downstream journey is nothing but the total time taken by the boat. This is one of the very important structures when it comes to the boats. Why like this? Why do they keep so simple? I don't know. Boats is really one of the simplest chapters. Of course, there are a couple of tricky questions which have been asked in the CAT, no doubt. We will see them in a while's time towards the end of this lecture. But this is one of the foremost structures we should kind of look at. Let's take a look at this. Therefore, what? Let's first elementary way of looking at this particular concept. Let's take a look here. A rower can row a boat 30 kilometers upstream and 44 kilometers downstream in 10 hours. Let's put this to perspective here. First statement, only the first statement, if I put it to the perspective, 30 kilometer upstream means 30 divided by, technically people write it like this, upstream speed is what? B minus W plus 44 kilometer downstream means people write it as 44 divided by B plus W. So what is this? This is time taken for the upstream journey. This is the time taken for the downstream journey. Upstream journey and the downstream journey. Time taken for upstream journey, time taken for a downstream journey is equal to total time taken. What is the total time taken? 10 hours. Total time taken is 10 hours. This is a very fundamental way of doing this. Is this what I want to teach you? Of course not. Of course not. So yes, but then all right, now first let's understand fundamentally how does it look like. All right, there is no harm doing one odd question in a very fundamental way to illustrate the point what we are trying to see here. We can also row the boat 40 kilometers upstream. All right, 40 kilometers upstream means this is the distance divided by speed, time taken for the upstream journey, plus 55 kilometers downstream, that is 55 kilometers at the rate of B plus W. That's a speed. So which would be equal to 13 hours. what is the speed of the water current. In the sense, now I need to understand that what is the value of W. Manipulation is fine. You may say that, sir, I will take B minus W, B plus W as the LCM. I will write it all of this. Fair enough. We can do this. But that is not how we write. Hereafter, what you do is let the value of X be equal to, listen to me very carefully here. I'll put it something like this because this is one of the very standard structure. Time taken for upstream journey, time taken for a downstream journey is the total time taken. Is one of the very, very popular structures that we get. Hereafter, what we do is whenever we get something like this, we convert them to the simple equations. How? 1 divided by B minus W, you take it as X. Let X be equal to 1 minus B by W. Let Y be equal to 1 divided by B plus W. Write 1 divided by B plus W as Y. In that case, how does the first equation turn out to be? 30x. You can write the first equation as 30x. You can write this 30x plus 44y is equal to 10. How do you write the second equation? Therefore, you can write it as 40x plus 55y is equal to 30. Now it looks like two simultaneous equations that I should solve. The solving becomes much more faster from here. Okay, fair enough. What I do is first I will take the difference between them. If I take the difference between them, it will become 10x plus 11y is equal to 3. Then what I do is I work first equation with this equation with the first one. I'll quickly help you how to solve these things. You can solve at your own pace. There is absolutely no problem. But I will tell you how we could work this little faster. So what you do is, hey, look at the second one. Get rid of this 44. If you want to get rid of this 44, take this master equation, multiply this by 4 times. If I multiply this by 4 times, it will become 40x plus 44y is equal to 12. This equation, after multiplying this by 4 times, results in this. Now what you do here? Use these two equations. Subtract the first equation. Let me call it as the first equation. Subtract the first equation from this equation. You will get it as 10x. 10x, this has become 44y, which gets cancelled. 10x is equal to 2. Therefore, x is equal to 1 by 5. Therefore, x is equal to 1 by 5. Beautiful. All right, next what you do? All right, now do the exact same thing out here. Look at this master equation. Look at this master equation. Now try to get rid of, all right, from here with the master equation. Work this master equation with this. Now let me call it as the second equation. Same master equation, work with the second one. So how does this look like now? There is a 40x here. There is a 40x here. Gets cancelled. 55y and 44y. You will be left with 11y, which is also equal to, there is a 13 here and there is a 12 here, which would become 1. Therefore, you say that y is equal to 1 divided by 11. Beautiful. X is equal to 1 by 5. Y is equal to 1 by 11. Come back here. What is the value of x? Substitute. 1 divided by b minus w is equal to 1 by 5. Therefore, this is the value of x, 1 by 5. Therefore, you say that b minus w is equal to 5. Similarly, second one, 1 divided by b plus w is equal to 1 by 11. Therefore, what is b plus w? B plus w is equal to 11. We all know how to get the values from here. B is equal to, because first value is b, we all know how to solve this kind of simultaneous equation, I guess. The value of b is 5 plus 11 divided by 2. The value of w is equal to 11 minus 5 divided by 2. Directly it comes 11 plus 5 divided by 2 becomes 6. 11 minus 5 divided by 2, w becomes 4. 6 on one side, 2 on the other side. 6 and 2 are the requisite answers. Okay, my point is, it's not about how to solve the simultaneous equation. Don't lose forest for trees. My point is, you always get this kind of structure. You find it very popular in most of the exams. You find this time taken for upstream, time taken for downstream is equal to total time. You kind of keep finding this very often. All you got to do during that time is convert it to two simultaneous equations and try to resolve this particular issue. Convert to simultaneous. That's a point. How do you convert to simultaneous? This is what you kind of use. Put immediately in your mind 1 divided by b minus w as x, 1 divided by b plus w as y, and let your simultaneous equation solving be sharper. If they are sharper, you will get your answers much faster and better. Type 1 is clear, my friends. Everybody, quickly give me the acknowledgement. Type 1 is clear. Type 1 is clear. Can I assume that the type 1 is clear, everyone? Type 1 is clear. This is type 1. What we did here is type 1. Quickly acknowledge. Very simple. Converting it to a simultaneous equation. Whatever you have in the denominators, convert it to simultaneous equation. Good. Stuti is fine. Yams is fine. Anybody else quickly confirm? Yeah. Right, that's your type 1, right? That's the type 1. Let's now take a look at type 2. Let's now take a look at type 2. What's another type? Let's take a look at the type 2 now. Good, Prashant. Yeah, nice. All right. A motorboat can travel at 10 kilometers per hour in still water. It traveled 91 kilometers downstream in a river and returned by taking altogether 20 hours. Again, similar structure. Let's see that then what is the difference here? Similar structure, the distance is constant, right? The distance is constant. It's a similar structure. Now this can be approached in many ways. Distance is constant, very similar structure. You would have taken time taken for upstream journey. You would have written 91 divided by b minus w plus 91 divided by b plus w. That's the time taken for the downstream journey, which will be equal to total time taken. What is the total time taken? 20 hours. I can solve it from here. If I solve it, listen to me, this will become 91 times of, so you already know your denominator, LCM, is b minus w and b plus w. It will take the shape of a quadratic. That is the point I'm trying to make. In a type 2, it will take a shape of a quadratic. You may wonder where the quadratic is coming. 91 I took common. Inside the bracket, you can write b plus w plus of b minus w. This is what you will be writing inside the bracket. W gets cancelled. Therefore, it gets a shape of 91 times of 2b 91 times of 2b divided by b square minus w square is also equal to 20. That is what something that you can that you kind of write like it appears like a quadratic. It appears like a quadratic function. Yes. So that's the second part. Second type of question is it takes the shape of a quadratic. Pretty simple ones. But let's see when it goes to the CAT questions how it makes a difference once we understand these two particular types in nature. All right. And let's also look at the alternative approach for this in a while. Okay, so therefore it's given the motorboat has a speed of 10 kilometers per hour. Substitute 91 times of 2 times of wherever b is there substituted as 10. 20 times of, I'm taking this on the other side, b square becomes 10 square minus w square. From here 10 2 times 20 gets cancels with this. Therefore w square is equal to 9 and hence w is equal to plus or minus 3. We'll take the current water flow as 3 kilometers per hour. 3 kmph becomes the answer. Now listen to me. Sometimes, all right, now this orientation is important. This orientation is important. Look at this master equation. Look at this master equation. If you believe in it, thinking that probably he might have given a nice number for water current speed, something like 1, 2, 3, 4, etc. Because if this question comes with a box, they generally don't expect us to type 2.5. They expect us to type either 1, 2, 3, 4, 10, something like this, right? Take this master equation, look at the alternative approach, 91 divided by, okay, I'm just writing it here, 91 divided by, I'm substituting the value of b. What is the value of b? 10 kilometers per hour. Therefore, 10 minus w plus 91 divided by 10 plus w will be equal to 20. Now listen to me. The value of 10 plus w is greater than 10. This is the value of 10 plus w is greater than 10 because the water will have some speed, the 1, 2, 3, 4, whatever it is. Because if this question comes as a box, it is generally going to be a natural number that you are going to type in there. So therefore, the value of 10 plus w has to be more than this. Now, what you do in this case is look for the factors of 91 greater than 10. Look for the factors of 91 greater than 10. See, 1 is a factor, 7 is a factor, 13 is a factor, and 91 is a factor. These are the only 4 factors of 91. Look for the factor which is greater than 10. You may say that, sir, I have 2 factors. 13 is one of the factors, 91 is one of the factors. Right? That is the idea there. Fair enough. Take one of them. Let 13 be one of the factors. You are trying to say that therefore 10 plus w is equal to 13. If 10 plus w is equal to 13, you are trying to say w is equal to 3. Come back, substitute and check. 91 divided by, you said that let the value of w be equal to 3. Therefore, 91 by 7. This is 91 divided by, you said that let the value of w be 3. You are checking it as 91 divided by 13. Check it out whether it is equal to 20 or not. Let's check. 91 by 7 is 13. 91 by 13 is 7, which is equal to 20. Satisfying the right hand side, and hence it becomes the answer. Which means that orientation is important. What you do is, in case the distances traveled are same, Look for the factors. If especially this question comes with a box like this, if this question comes with a box, generally they want us to fill it with a natural number. They don't want us to fill it with 2.25, 2.73. No, that is not what they want us to fill us with. They want to fill us with a natural number. If it's a natural number, take the factors of that particular distance, take the factors of the distance and try to close it. With good superior numerical skills, these things will take just about 30 seconds to close it, because you read it, you already know the structure. Time taken for upstream and time taken for downstream is total time taken. Because you already know this particular structure, you can easily, the moment you read that question, you fit these elements into the structure. This is what you fit. You quickly fit these elements. Look for the factors of 91. Check one of the factors quickly and close this particular issue. All right. Type 2 is clear. Type 2 is clear. Type 2 means it appears like a quadratic. It appears like a quadratic. Distance is constant. In a type 2, what happens? The distance remains constant. Unlike type 1, where you write it like an equation, in this case, the distance remains constant. Comfortable? Everybody clear on this? These are the two major types. These are the two major types. Rest are all minor. Okay. Kushagra says fine. Is this clear? The approach is clear. Taking factors also is clear. You can take the factors and you can check. That is also fine. Right? Okay. Stuti is clear. Prashant is clear. Very good. Good, my friends. Very good. Very good. Very good. All right. This is the cat question for you. Good, Yamch. That's right. I'm not sure whether your name is Yamj or something. If your name is different, you can put your name. I will try to remember your name. You logged in as Yamch. If it's something else, so you can just put it there so that it would be convenient for me to acknowledge. Okay, this is the question for you. Answer this, then I will go to the deeper cat questions in a while. Answer the simple cat question in a minute's time. Whichever method, identify and quickly finish it in a minute. All right. Okay, I will still wait for 30 seconds for you. I will time it myself. I will wait for 30 seconds. I'll wait for 30 seconds. Close it. I want you to really close this question. Simplest question. We've been doing times per distance for such long. Close this. 20 more seconds. Ten more seconds. Okay, that's about 1.5 minutes now, right? So that looks like quite a time. That's quite a time. All right, do it with me. I give sufficient time out here. Let's try this. So one way of looking at this. See, this is much simpler than the questions we did. We said that, hey, I can take the upstream speed as x. What is the x in our mind? So by now, this will be in our mind. That's my point. By now, this would be in our mind. Listen to me. X is nothing but 1 divided by b minus w. By now, x should be in our mind. It's not that, hey, it's already fixed. That's what the learning is. Learning means putting certain things in the autopilot mode. We don't think. We simply do. That is what practice means. Okay, now it's very, I just solved a question. It's very difficult to put things on the autopilot mode. The point I'm trying to make is put things in the autopilot mode, which means really without thinking, you do half of the things in the exam. You really don't think. For example, if I'm solving some questions, I don't think and solve them. It just happens. For example, okay, I will give a classic example on putting the things on the autopilot mode. Tables of two. Should you have to think to tell me the tables of two? No. Should you have to think to tell me the tables of three? No. All right, no, certain tables. I'm just giving an example because some of you might not understand what I meant by this autopilot mode. Autopilot mode means you just do it. For example, if you know how to drive a car, so do you really conscious about where is your steering, where is your clutch, where is your gears? No, you kind of do it in the autopilot mode. Your right hand does what it should do, your left hand does what it does, your right leg does what it should do, your left leg does what it should do. That's what you mean by putting the things on the autopilot mode. It's all in the brain. When you are sitting on the driver's seat, so if these things can be put on the autopilot mode, some of our learnings also can be put on the autopilot mode. How do you put it? Repeatedly do the same things, repeatedly do the things, and do them mindfully and put them in the autopilot mode, which means when I'm doing time square, when I'm doing the boats, when I say x means 1 divided by b minus w. That's autopilot mode. Simple. I can simply write it as x hereafter. Fair enough. So what is downstream? Downstream is y. Alright, y means 1 divided by b plus w. You may say that, no, sir, I will call instead of x, I will call it as a. Put it in your own style in the autopilot mode. It is x you want to write or a you want to write. That really doesn't matter to me. But putting the things on the autopilot mode is important. Be it your verbal, or let be it your grammar in the verbal, or be it your LRDI, some of the sets, or let know be it your quant, you have to put certain things on the autopilot mode to generate the speed. Otherwise, you can't generate the speed. Take my words, you can't generate the speed. These are very practical things what I'm trying to tell you here. Fair enough. Let's come back to this. Let's understand this. So one way of dealing with this is what? 40x, because upstream is nothing but x plus 90y. 90y is equal to how much? 5 hours. What do you mean by 40x? That is nothing but the time taken for the upstream journey. What is 90y? Time taken for the downstream journey is equal to 5, because we already studied the concept. What is the point again trying to explain all this? Okay. Second part, it also takes 60x upstream, 60 kilometers upstream, 60 kilometers downstream, that is 60y, is also same as 5 hours. Now look at this CAT question. Such beautiful. He's making the time equal. Equate both of them. Therefore, you are trying to say that 40x plus 90y is also equal to 60x plus 60y, because both are 5 hours only. Equate them. You don't even have to solving, as it reduces so much time. That's the reason I said that do it in a minute. It doesn't require more than that. Therefore, you say that 20x is equal to 30y. Fair enough. What is the value of y, man? 30 divided by, substitute for y. Y is nothing but b plus w. All right, what is this? 20 divided by, substitute for x, which is nothing but b minus w. This is cancelled. Simplify them. So therefore, you get 3b and 2b. Therefore, b is equal to 5w. B is nothing but 5W. Okay, where should I substitute this to get the answer? Go to one of the equations, substitute and finish the deal. 40 divided by, what is the value of x therefore? Now look at the value of x. X is nothing but 1 divided by b minus w. Substitute, what is the value of b? 5w. In place of w, substitute 5b. Therefore, 40 divided by 4w plus, for this also you write 90 divided by y. What is the value of b? B is nothing but 5w. Substitute 5w plus w is nothing but 6w is equal to how much? 5. What we want w only. Water current is w. So you may think that, sir, why you are substituting b in terms of w? Because I want w. I will never lose focus on what I want. All right, I never lose focus on what I want. Therefore, I'm writing in terms of w. Substitute. Therefore, 10 by w on one hand, 15 by w on the other hand is equal to 5. W is the common base. Therefore, 25 by w is equal to 5. Therefore, w is nothing but 5. Simple. Therefore, the water current speed is 5 kilometers per hour. Simple, guys. This is what I technically taught you. Equation, right? Time taken for the upstream journey, time taken for the downstream journey is nothing but time taken for the total journey. This is what I taught you. And in this CAT question, author has made the question even more simpler by giving the same time. So therefore, solving time becomes much more easier. But I have to put certain things in the autopilot mode. Is this making sense what I'm trying to say? We have to generate speed by putting certain things in the autopilot mode. It will take time. It will take time. But having that thought is important. If you don't put certain things in the autopilot mode, it is going to take time and it will also going to tire you out. Making sense? This question is clear, everybody? Hello, quick. Are you all learning something? Are you learning something? Making sense? Put in the chat. Good, Mohit. Firstly, tell me how many of you are not sitting with a book. Are you guys sitting with a book and a pen? Are you guys sitting with a book and a pen? Are you guys sitting with a book and a pen? Are we having the right learning attitude? Yes, no. I know that. Okay, some of you are very regular. I know. I can ouch on Mohit. Yeah, Kushagra, I can watch Stuti. Yes, right. And who else? Who else? I don't know much about others. So you have to confirm me on this. Some of them I'm sure of. Right, yeah, others also. Right now, others also. I encourage you to sit with the right kind of attitude. Don't keep watching, you will not learn. So, when I give some time to do certain CAT questions after giving the orientation, it makes sense to try it out. Always sit, all right, even when you are watching this. I know that, okay, simply you want to watch some video. Whenever it is possible, carry a small notepad in your pocket, all right, or in your bag, or keep it beside you. Take that notepad and pause that video and try to work on this, right? Yeah, something like that. All right, yeah, all right. So that is what it is. Yes, what is that you are trying to say, Kushagra? What is the problem here? The speed of the water current is 5 kilometers per hour. More than 5 hours, you are trying to say. What is more than 5 hours? No more than 5 hours. It's a 5 kilometers per hour. That is the speed of the water current. Where is that confusion? Right? What is that 40 by 25 and 90 by 15 you are trying to do? W, we got it as this. Yes. Average speed 20. What is the average speed here? From where you are getting the concept of average speed in between this? There is a resultant speed. There is no average speed here. There is an effective speed, Kushag. That's not average speed. That's not average speed. It is the resultant speed, effective speed. There is no question of average speed here. Don't bring in average speed. It is a resultant speed. Don't confuse between, it's a concept of relative speed. Since both moving in the same direction we add, don't bring in the concept of average speed inside this. Right? So let's talk about this. Here it is the concept of resultant speed or effective speed. Nothing but a modified version of relative speed. Right? Okay, which it's clear now. Very good. Yeah. Yeah, that's right. Yeah, sometimes it happens. We think sometimes wrong. Correct them. You ask me, I will tell you. So where you might be thinking wrong there. All right. So here we go. The next one, beautiful cat question. Beautiful cat question. Again, I will give you 2 minutes. It's worth it. Worth it. You try it. Worth it. Because I already gave the concept. Why not try it out? Why not try it? Yeah, go ahead. 2 minutes is on the higher side, but it is worth that. Since we are learning, I will allow sufficient time for you to think. Go ahead, think about this. Okay, guys, it's time. It's time. If I give a little more time, I'm sure already will do them. Not a worry. Yeah, not a worry. Already Kushagra has punched in some answer. Let's try to take a look here. Okay, this is the model 2. The first question what we did was type 1. The second cat question that we are doing is a type 2. I already taught you these two models. I said the importance of these two models. Second model takes the shape of what? Quadratic, right? Okay, let's take a look here. How does this take that particular look? At his usual rowing rate, Rahul travels 12 miles downstream in a certain river in 6 hours less than. What is the second model? First model is different distances, right? What is the second model? Which means upstream distance is different, downstream distance is different. That is the typical model 1. What is a typical model 2? Whatever he travels upstream, he travels the same downstream, distance constant. That's how you should remember. Okay, different. The upstream distance and downstream distances are different. Model 1, autopilot mode, put it and then resolve it. Second model, upstream and downstream distances are same. Put them to perspective and solve them. Okay, let's take a look here. Rahul can travel 12 miles downstream in a certain river, 6 hours less than it takes him to travel the same distance upstream. Fair enough. What we are trying to say, 12 divided by, so that's a 12 is the distance. I'm now talking about the downstream time. The downstream time will be b plus w. Naturally, it takes lesser time. What is the upstream time? 12 divided by b plus w. What is the difference between them? The difference between them is 6 hours. Second one, 6 hours, right? That's what he's trying to say. 12 miles downstream in a certain river, 6 hours less. This is the downstream time taken for the downstream journey. This is the time taken for the upstream journey. What is the difference? The difference is 6 hours. That's the point number 1. That is what he is trying to say there. Second point. What is the second point he is trying to make? But if he could double his usual rowing rate, what was his rowing rate? B. So double his usual rowing rate means 2B. And he travels 24 miles round trip. Round trip means what? Go up 24 and come down 24. Fair enough. What is the second one therefore? 24 divided by, let me write it here, 24 divided by 2b plus w minus 24 divided by 2b plus w would be equal to how much? 1. All right, 1 hour less than upstream 12 miles. Sorry, 12 plus 12. 24 hours round trip means what? 12 plus 12 again. 12, same 12. Had a double the speed, same. All right, 12 miles down and 12 miles up. 12 miles because 24 miles round trip means what? 12 miles down and 12 miles up. This is what author is trying to comment. Fair enough. Let's quickly come to the perspective. How do I write this? 12 times of denominator is b square minus w square. No doubt the denominator is b square minus w square. So numerator I'm writing 12 times of, I'm substituting them, b, hang on, so upstream is b minus w, yeah, b minus w, b plus w. When you put them to perspective, you will be getting it as 2w. You get 2w in the numerator, which is equal to 6. This is what you get as one equation. All right, this would become one equation. All right, yeah. Similarly, the second one, 12 common. So I will put the other, so denominator will be 4b square minus w square is equal to 1. So what will be remaining in the bracket when you put them to perspective? 2b plus w minus of 2b, and see this is minus, sorry. All right, minus of minus becomes plus. Therefore, it will become 2w. Fair enough. Now look at this. I'm comparing these two equations. This is same. Okay, any which way. So now let me write it to the perspective once again. 12 times of 2w is also equal to 6 times of b square minus w square. Here 12 times of 2w is also equal to 1 time of 4b square minus w square. You understand that hey, left hand sides are equal. Left hand sides are equal, therefore right hand sides can be compared. Quickly the right hand sides can be compared, and hence you say 6 times of b square minus w square is also equal to, I'm comparing this along with this, which is also equal to 4 times of b square minus w square, and hence you say that 2b square is also equal to 6b square, which will also be equal to 5w square. 2b square will also be equal to 5w square. Fair enough. But what is the question here? The question is, therefore his question is, what is the speed of the current in miles per hour? What is the speed of the water current in miles per hour? I want the water current speed. So how do I get this water current speed? Therefore, substitute. You want water current speeds, W is required. If W is required, substitute for 2B. Substitute for this. So where I will go? I will go to this equation now. I will simply go to this equation. Any equation is fine. Any equation is fine. There is no hard and fast rule there. Any equation is fine. Okay. Therefore, what is 2b square? If 2b square is equal to 5w square, then 4b square will be equal to 10w square, doubling both of them. Therefore, this is 10b square, 10w square minus w square will also be equal to 12 into 2 times of w. Fair enough. Therefore, you are now saying that 9w square is also equal to 12 into 2 into w. 1 w gets cancelled. 1 w gets cancelled. 3 times, and this becomes 3 4 times. Therefore, you say that w is nothing but 8 divided by 3. Pretty simple question. Pretty simple question. To explain it takes time, but if you are trying to resolve it, you understand that hey, the distances were constant here, the distances were constant. Simply you would have noticed that already you will get this portion pretty faster. Let these two equations you will get pretty faster, and you solve from there and you will get your answer. Fair enough. Did it make sense? The model 2 question by CAT, did it make sense to you? Clear, everyone? Type 2, we did one question of type 1 and from CAT. We did one question of type 2 from CAT. Now I will go to another type. So these two are clear. These are the two basic models on time and work. Times are the basic models on both and streams. This is a very basic model. Basic model on the both and streams. Two basic models are clear. We look at the variations now from CAT. Okay, Kushagra is fine, Stuti is fine, Prashant is fine. All right, very good, very good. Yeah, these are the two basic models. Now there will be some small nuts and bolts. I'm not interested in those nuts and bolts. That will be taken care. That is no big deal out there, right? Yeah, but then models, all right, every lesson has certain models which we need to be kind of clear with. All right, guys. So we know that, okay, every day at 2 p.m. I'm running the course on the DILR Classics. That's every day at 2 p.m. That's Monday to Saturday, right? And then every day at 10 p.m. or this is 10 p.m. 10 in the night, we are running the course on QA, right? So to keep attending them. At times, the same two courses I will run on the Unacademy app. That's also free. All right, free lessons, but that comes on the Unacademy app. So Unacademy app, if you are not downloaded, use the code Belvi100 and download it. So you can also meet me there on some of those particular days, right? So let's keep that in mind. And all right, now let's now go to one of the classic questions asked in CAT. Once I will come to two classic questions. I think let me start with the classic question itself. Beautiful CAT question. Beautiful CAT question on boats. Beautiful CAT question. Try this. I will give you 2 minutes. This is the classic question. You can by heart this question after this. By heart and remember. The classic CAT question worth by hearting also. Everyone has to put this question in the autopilot mode after I explain, even if you are not able to crack it. Go ahead. Okay, all right. If I give you a little more time, you will be able to think and close. There is no problem on that. Okay, now listen to me. Very carefully listen to me. We have to put this question in the autopilot mode. It's very, very important, right? Because you will get a lot of questions of this particular nature. This is another type I'm talking about. So here is the clear cut relative speed which comes in the picture. Listen to this. right? So this Finn, all right, this particular person is rowing upstream the river, all right? Say he's rowing upstream this particular river. So there is one particular point, his starting point. Let's say that in this river, this is the starting point. River goes on. There is nothing like that. So there is a river. All right. This assume that he started rowing from here. The Finn started rowing from here. Finn start. Then he reached a particular point. Let's say the starting point. Let me call it as S. Then he reached a particular point. Let me call it as M. Just like that, I'm calling it as M. What happened is here. All right now. So here his hat fell down. His hat fell down, hat started moving in the opposite direction. After that, what Finn did is he wrote, all right, now he already wrote for 5 more minutes. That's given. 5 more minutes. All right, now hat fell down. He didn't mind. He realized after 5 minutes. So hat fell down because of wind or whatever. He didn't realize it. He all right, now he went down. So which means he went to this particular distance. Finn reached here. Then he turned back. He went till here and then he immediately turned back. He realized my hat has fell down and he turned back. Now listen to me. So from the time the hat fell down, listen to this very carefully. What happened in these 5 minutes? I'm talking about what happened in these 5 minutes. Let's understand this. From the point M, what has happened? Let's call this as point M. So at the point M, when the hat fell down, so from there, the 5 minutes time, let's see what all has happened there. Finn had a speed. There was a speed for Finn. The hat also was moving with certain speed. Now let me write the relative speed and let me write the distance between Finn and hat. Therefore, what is the distance between Finn and hat at the end of these 5 minutes? I'm analyzing the speed 5 minutes. In this 5 minutes, the Finn was maintaining a speed of boat minus water because he was going against the stream. Fin was traveling in this direction. What is the speed of the fin? If I ask what is the speed of the fin, you will say that B minus W because he is going against the water stream. So let us say his boat speed was W, the boat speed is B and the water current speed is W. Therefore, B minus W. What is the speed with which hat was traveling? It was traveling with a speed of W because it is going along with the river natural flow because hat does not have its own speed. It is moving with the speed of the river. Therefore, water current W. Okay. What is the relative speed? Now, so fin is moving in this direction. Listen to me. Fin is moving in one direction. Hat is moving in the opposite direction. Relative speed is nothing but the sum of the speeds. Relative more speed is nothing but the sum of the speeds, which means B minus W plus W. Why? Because hat is moving in one direction. Fin was moving for those 5 minutes in another direction. So what I should do for the relative speed? Add those speeds. B minus W plus W. Therefore, what is the relative speed? B. That is the relative speed. What is the distance covered? Therefore, at the end of 5 minutes, what is the distance between fin and the hat? The distance between fin and the hat is speed into time. Hey, what is the speed? B kilometers per hour. What is the time? 5 minutes. All right, I have to write this also in write this in hours. Let me write it as 5 minutes. Let me write it time B. That is the distance. I know that it is in terms of minute. Let me keep it there. If I do 5 by 60, I will get it in terms of hours. I will do that later. That's not a worry here. So I will do that later. Speed into time. Which speed? Relative speed. Into time. How much time? 5m. That is the distance. I'll say that therefore the distance is 5b. 5b, something like that. Okay, where is that particular distance? Somewhere here. Say that the hat has reached this position. Somewhere here, the hat has reached this position and Finn has now reached this particular position and he is ready to turn back. Finn has reached this particular position, hat has reached this position. This is the gap which I am calling it as 5b. This is the gap I'm calling it as here. B into 5, I'm calling this as 5B. In my mind, I'm just calling it as 5B. Now listen to this. Now listen to this. Now second part. Now the fin has turned back. Listen carefully. The fin has turned back. Therefore, what is the speed of the fin? Case 2. The speed of the fin is B plus W. Because fin has turned back. When the fin has turned back, what is the speed of fin? B plus W. What is the speed of the hat? It is W because hat will be still moving with the speed of the water current. It is still going to be W. What is the relative speed? Since both of them are traveling in the same direction, relative speed is nothing but the difference between their speeds. Okay. Therefore, B plus W minus W. What is B plus W? The speed of fin. What is minus W? That is nothing but the speed or speed at which the hat is moving. B W cancel. Therefore, the relative speed is B again. The relative speed is B again. Now, let me tell you, let me ask this. How much time fin will take to cover this extra distance called 5B? Right? Therefore, the time taken to meet. In the relative speed chapter, I talked you about this. Time taken to meet is nothing but extra distance to be traveled by extra speed available. What is that extra speed? That extra speed is relative speed called as the extra speed available. Therefore, it is equal to 5 minutes. You may say that, how do you know, sir, it is 5 minutes? You said that this 5 is in terms of minutes. Be mindful about it, which means Finn is going to catch this hat in 5 more minutes time. 5 minutes he went up. Then he realized that the hat has fell down. Then he turned back and went already no, came already turned back and rode his boat. And in 5 minutes time he has caught this. But by the time he caught it, author is trying to tell that the hat has reached the starting point. Hat is already here, which means Finn was also here. He caught it at this particular place where he said that real fear. He turned back and caught up with the hat just as it reached the starting point. It reached the starting point. Now come to the hat. Analyze the hat. Hat traveled for how long? 10 minutes. Hat traveled for 10 minutes. You may wonder, how, sir? Because Finn went for 5 minutes up and then Finn came down for 5 minutes down to catch this particular hat, which means hat traveled for how long? 10 minutes. What is the distance covered by hat in 10 minutes? 1 kilometer. How do you know 1 kilometer? Because hat was dropped after traveling 1 kilometer. Hat fell into the river. When he had covered 1 kilometer, after traveling 1 kilometer, hat fell down in the river. Therefore, the distance covered by the hat is this S to M, which is nothing but 1 kilometer. Hat traveled 1 kilometer in 10 minutes. That is what we are trying to say. Therefore, what is speed of the hat? Speed of the hat is it traveled 1 kilometer in 10 minutes. But the point is, I don't want kilometers per minute. Answers are in kilometers per hour. Fair enough. Let me convert minute. If I want to convert it to hour, 1 by 60 I will do. Now it has become hour. Kilometers per hour. Therefore, speed of the hat has become 6 kilometers per hour. See, no, look at this. Why I wanted you to put this in the autopilot mode. There is an effective speed and relative speed in the same question. In the same question, both effective speed and relative speed are coming in the picture. Beautiful question. Beautiful cat question. You may say that's our speed. This one, man, when you used to write B minus W, it is an effective speed. This is an effective speed. When you are writing here, all it hat versus this man, this is called as relative speed. In the same question, both relative speed and effective speed are coming in the picture. What I want you to do is listen to this part of recording once again after this particular lecture. Put this question in the autopilot mode, because both relative speed and effective speed are coming in the picture in the same question. It's a rarity, but it's a surety, which means this kind of questions will be asked. Double thing. When the questions get difficult, both things will get kind of matched up. Are you with me, guys? Is it making sense to you? Did you observe the phenomena of effective speed and relative speed coming in the picture in the same question? Is this making sense? Go ahead, confirm me. Did you understand this? What I'm trying to talk here? Did you understand this? Okay. Stuti partially understood. I know, because it's a double whammy. Two things happening at a time. Very challenging one. Right? Yeah, it takes time to explain. Okay, Kushagri, want me to explain 1 kilometer in 10 minutes? Okay, Mohit, you want us to do once again? All right. What we'll do is let's do this once again. All right, because I said that you have to put this in the autopilot mode. No problem. We will do this once again. Okay, let's do the whole thing once again. Don't worry. All right, no, because there were two things here. The confusion is because of two things. There is an effective speed, no doubt, when the boat is moving and the man is rowing that particular boat in the river. That is called as effective speed. But the hat with respect to the man in the boat is becoming the resultant speed. Two things are happening at a time. Okay, now again, I will this whole question. Please read, all of you read the whole question once again. Just take 20 seconds. 20 seconds and read and commit the question in your mind first. Put the story in your mind. I will explain the calculations behind the story, but put the story in your mind. I'll give 20 seconds. I'll time it. I'll count it myself. Read. 10 more seconds. Okay. Yeah. Storyline should be clear. Now I will not repeat the story. Right. I already explained once. Now you read the story once again, but I wanted you to put that storyline in your mind. Okay. Now listen to this carefully. Listen to this. What's happening? The river is moving. Somewhere there is a starting point. Assume that this is where the man started. River is just going from one end to the other end. Let's say that this is the starting point. Let us call this as S. Right? There is Finn. This Mr. Finn want to. It's a Mississippi River, one of the very famous, world famous river. Call it Mississippi, Mesopotamia. I don't know. All these are the civilization based kind of rivers. Anyway, that's a geography different issue. Okay, yeah, Finn has started here. The Finn has started his journey here. That's what you are trying to say. Starting point. The Finn started his journey from this particular place. He rode 1 kilometer. This 1 kilometer is SM. Listen carefully. S to M. The distance from S to M is 1 kilometer. At M, the hat fell down. He was wearing a hat, it fell down. So naturally, the hat will flow down the river. Hat does not have any speed. Hat cannot challenge the river saying that now I will also come up along with you. No. All right, now that will be going down. That hat fell down when after traveling 1 kilometer. 1 kilometer hat fell down. It is explained in the story. After traveling 1 kilometer, hat fell down. But he didn't realize because of some cool breeze or whatever, he didn't realize. Then he traveled for 5 minutes. All right, he reached here after 5 minutes. After 5 minutes, he reached here. After 5 minutes, if he reaches here, hat will not be here. It is not stuck there, right? In that 5 minutes, the hat will also reach some place. Assume that hat reached here. Therefore, this is the gap which was created in 5 minutes time. Hat fell down, but the fin went up to point N. Fin went up to point N in 5 minutes. In that 5 minutes, hat will not be here. Hat will not be stuck at the point M. Hat will also be moving. Let's assume that in 5 minutes, the hat moved this particular distance. I'm hatching some particular distance. You want to name it. Let us name this particular point as K. Hat moved in the same 5 minutes. This. Now listen to me. So effective speed is there. Resultant speed is also there. Listen very, very carefully on this. Now one, Fin. Fin has the effective speed. In this 5 minutes, I'm analyzing what happened in the 5 minutes after hat fell down. Hat fell down, but what happened in that 5 minutes? Fin was moving with a speed of B minus W. Hey, why B minus W? Because he is going against the water current. Fin was going against the water current. So Fin's boat had a speed of B, but since he is going against the water current, his effective speed will be B minus W. Correct? What was the speed of the hat? Speed of the hat is W. Why? Because it's just going down the river. Hat is just going down the river. It is going to be W. Now, therefore, what is the relative speed between the fin and hat? What is the relative speed between fin and hat? Relative speed is because hat is moving in the opposite direction. Fin was going in this particular direction at M. What did happen in that 5 minutes? Hat was going in one direction. Fin was going in the other direction. Therefore, what is the result? What is the relative speed? F minus W, B minus W. For fin, I'm recording this particular number, B minus W. B minus W. For hat, it is W, opposite sides. Therefore, I'm adding them. W cancel. Therefore, the relative speed is nothing but B. Okay. Therefore, what is the distance traveled under the relative speed? Distance traveled under the relative speed is speed into time taken. What is the time taken? Time taken is 5 minutes. I know I'm supposed to be writing this in hours. I will just write it in minutes and keep it in my mind. Towards the end, I will do that calculation because towards the end, I have to write in kilometers per hour. That I will do at the end. Why do the calculation right from now? So, okay, I will write it as 5. M is in terms of minute. Let's say that therefore the distance between them is 5b. Hey, what is 5b? I will go with the green color. Now, this is 5b. This particular distance is called as 5b, the green colored distance. What I wrote in the green colored distance, this distance is 5b, which means after 5 minutes, hat is here. I'm going with the green color now. Hat is here. Fin is here. And now he turned back. After turning back, he realized the hat is at a distance of 5b, where 5 is in terms of minutes. The distance is 5b between them. Now, so what is this? The moment Fin turns back, what is his speed now? B plus W. The moment he turns back, what is the effective speed of Fin? B plus W, because the boat speed is B and the water current speed is W. Therefore, now it has become B plus W. Okay, what is the hat speed? Hat is still going with the speed of W. It is still going with the water current speed, right? Okay. What is the relative speed now? Because since both are moving in the same direction, relative speed is nothing but Fin's speed minus hat speed. Relative speed is the difference between the speeds cancelled. Therefore, what is the relative speed? Back to B again. Okay. Now, therefore, now listen to this. How much time Fin will take to meet the hat? All right, if you want to gather his hat back, he want to catch his hat back. That is the whole idea. How much time? All right, now Finn will take to catch his hat. He has to cover the relative distance. Say, what is the distance? The extra distance 5b. That is the extra distance between them because Finn, when he turned back and saw the hat, there was a gap of 5b between them. That is the relative distance. What is the relative speed? The relative speed is b. All right, relative speed is b. Therefore, the time taken by Tim to meet the hat is 5 minutes again. 5 minutes again. He took 5 minutes. Now he went upward in 5 minutes. Then he returned 5 minutes downward, which means hat has traveled for how much time? 10 minutes. Yeah, why 10 minutes? Finn went up for 5 minutes, then turned back, came back for 5 minutes to catch the hat, which means hat has traveled for 10 minutes. Are you getting this now? Kushagra, 10 minutes is clear, buddy. Is this clear? Is this 10 minutes clear? Everyone, 10 minutes clear? Stuti, Kushagra, Mohit, whoever is there, Prashant, all of you guys. Is this 10 minutes clear now? Hat traveled for 10 minutes is clear. Clear, 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 quick. Good. Right. Perfect. Perfect. Mohit, are you there? No confirmation from you? Time taken to come and catch the hat was another 5 minutes. Correct. 5 minutes he went up, Kushag, and then he took another 5 minutes to come down and catch the hat, which means hat was in the water for 10 minutes. Hat was in the water for 10 minutes. In that 10 minutes, what is the distance covered by the hat? This is the time for which the hat was in the water. It was in the water. Therefore, what is the distance covered by hat in this 10 minutes? Simple. So he said that then he turned back and caught up the hat just as hat reaches the starting point. Hat reaches the starting point means hat traveled from M to S. This is where the hat came. Finally, when Finn came and caught the hat, it was back to the starting point, which means what is the total distance traveled by hat from M to S, which is 1 kilometer. Right, therefore the distance traveled is 1 kilometer. Therefore, what is the speed of the water current? Speed of the water current is nothing but the time, or it's nothing but the distance traveled by hat and the time taken by hat, because hat was following the water current speed only. Therefore, what is the distance traveled by hat? 1 kilometer. What is the time taken by the hat to cover this 1 kilometer? 10 minutes. 10 minutes. Convert 10 minutes to hours, it will become 10 in 10, or 10 minutes divided by 60. All right, divided by 60. You convert the 10 minutes to hours. Therefore, what is the speed of the water current? 6 kilometers per hour. Beautiful question. So why I'm calling it as a beautiful question? It has both effective speed and relative speed coming together. Effective speed and relative speed coming together. This is one of the most beautiful CAT questions. After this, similar kind of questions were asked in many other exams. Is this making sense to you? All clear now? Kind of understood? If you didn't understand, now I don't think I have enough patience to explain this once again. Right? You can listen to this video once again. Listen to this. All right, now you can go back to this recording and then like you can listen to this once again. It should be clear. I'm positive that it must be clear by now. Just in case still you have some element of doubt, please go back. Please go back and listen. That would be more encouraging. All right, guys, if you are liking this particular video, in the sense, not the video in the sense like the content that we are discussing here, this is the time you press the like button. This is the time you press the like button. Online, offline, doesn't matter. Whenever you like something, yes, yeah. So you can always put, you can put that and share the link with others as well. Let them also taste it. Let them also join us at 10 o'clock. It's nice to let a lot of people, if we can gather at 10 p.m. and do the discussion, it will be much more lively. When you are downloading the app, use the code Belvi100 or whatever it is. Use your code Belvi100. If you have not liked it, right after the class, like it, or right now, if you have the access, like this and share it with your friends. Let's not say that together we can grow. It is not that only I should do, you should do. Together we can do. I've seen this things, systems working together much better in teams. Let's try that. Let's try that. All right. So let's go to one last question. Let's go to one last question. Beautiful question. One last beautiful question. Oh, you want to wind up? You want to wind up? Take this as a homework. Then I will discuss this. Take a screenshot. Take this as a homework. Beautiful question. So sure, all right now. So because some of you all right now it's turning out to be time, no worries. Take this as the homework. Beautiful question. No problem. Take it as a homework. Then I will discuss in the next class. Right? In one of the classes we'll discuss. Okay? Right. All right. Fine then. So I will see you on Monday at 2 with the DILR Classic. All right, bye till then. And the closure comments, some of you already know those who want to understand a little bit what is happening there. So this is what is that. On the plus, there are some recent batches which are just started, and some of the finest educators are they're teaching in those particular batches. So you can already now also join some of these batches. Sure. If you're taking any subscription, use the code Belvi100 all right, to download or to get the 10% discount. All of this. Yes, Shashwat, great. Yeah, good, good. Yeah, if it is all at 1:1 mentoring, all right, you can use this particular code and go for 1:1 mentoring if it is necessary. All right, then if you're looking for CAT 22 kind of, then there is a 12-month subscription or the 24-month subscription. If you're going for CAT 23, you get 3 months of additional subscription free. And if you have not taken the combat yet, all right, this Sunday can be the day. That's tomorrow at 12 in the afternoon. You can take the CAT combat while taking the test. Use this particular code, and there are some great scholarships that are on offering. So there we go. So I will stop here. Yes, all right. Good night. I will see you tomorrow. I'll see you on Monday at 2 p.m. Stay blessed. Catch you there. Yeah, if you want to leave any comments, the live chat will get ended now. So you can always put it in the comments. If something you want to put it in the comments, you can use the comments. Comments can be used even during the offline as well. I will come back, look at some of those worthwhile comments, and I will address them. Good night, guys. Good night. Good night.